Well, hello there. KP the Math G. This is the second day of the new year, January 2024. I'm doing my 51st video, my first of this year. And I am delighted to still be doing this. And I trust that I'll be doing this for quite a while. So anyway, we're dealing with separation of variables, and we're finding a particular solution, and this is actually part 2. The reason it's part 2 is that this problem's a little more difficult to handle than the other 2 previous problems that we could just do in just a matter of minutes. We're just going to take our time with this one, so let's get started. First of all, I want to rewrite this problem, okay? This is like e to the a minus b. You know the rule for that? How can we rewrite this? Yeah, that's right. E to the a minus means divided by e to the b. Alright, so let's rewrite that. dy over dx is equal to e to the 3y over e to the 2x. Okay, erase this. Bear with me. First of all, before we go any further, I want to say that I appreciate you tuning in and watching this. I noticed that I have quite a few people who have been watching lately, and I'm very happy about that. I thank you for your confidence in me, and I trust that I will continue to help you in every way that I can. That is my purpose and my goal, to do that. So just a little side note, I'm very appreciative of you. I just want you to know that. Now, whoa, okay. How do we separate this? How do we need to somehow get e to the 2x with dx and e to the 3y with dy. Well, the first thing we need to do, let me get a different color here, is we want to multiply. I want to get rid of this dx. That's kind of my first thing here. Let's get rid of dx, and I want to multiply both sides by dx. Alright, so what we have here is dx times dy over dx is equal to e to the 3y over e to the 2x times the very thing we're multiplying both sides by is dx. So look what happens here. These divide out, right? And we're left with dy being equal to e to the 3y over e to the 2x dx. Well, I still have a problem because I've got a y with the dx, don't I? I got my 2x, e to the 2x over here, where it needs to be. This needs to be over here. How can I get rid of that? That's in the numerator. So if I can maybe somehow get this over here, I can work with it, right? So I can make this, if I multiply by 1 over e to the 3y, I can do that to both sides, can't I? Alright, so let's try that. So let's see. Get a different color. Alright, so 1 over e to the 3y. Now, do you see immediately that I can divide these out? That's the idea. Think about what you can do so that these will divide out. Alright, so I'm going to do it to the other side. So 1 over e to the 3y. Alright, that's in the numerator. That's an exponent there. Okay, so look what the left side is. Okay, it is 1 over e to 3y dy is equal to, now look what happens here, these divide out, so I have actually really, this is a 1 now, so 1 over e to the 2x dx. No. See that? You know, I kind of, you know, you get tempted to say, well, this is a du. I mean, this is a ln function. It is not an ln function. Okay. Why is that not? You know, you can just say, hey, I can just write dy over and make this ln. Why is this not an ln? Now, dy over y is ln. dx over x is ln. This is dy over e to the 3y. So this is not an ln function. And students, let's get that straight in our mind. I know it's tempting for me to do that also. When I was a student as well, I had to learn that I couldn't do that. So Jiminy Cricket, what do we do? I don't know a Jiminy Cricket, do you? Just a joke, and it's a bad one, as usual. Look here, remember 1 over a to the n is equal to a to the negative n. Remember that? I'm going to just bring this and make this exponent negative. Alright, so I can do that. So e to the negative 3y. Bringing that up here, dy is equal to, same thing here, same reasoning, e to the negative 2x dx. I've separated my variables. I've kind of rewritten it again and just kind of did, didn't I? Okay? So to separate, first of all, you have to remember this rule right here. You got to remember that. This been pluses, this would have been times. This is minus, so we divide. First divided by the second one. Then I have to get rid of my dx in my denominator, and I have to match x with dx and y with dy. Something of that form, and we got it in this form here. Y with dy, x with dx. Happens to be e to the 3y, and this happens to be e to the 2x. Okay, it's fine. Now, being in the denominator, I can shoot this up in the numerator, and I've got it. Okay, so now, get a different color. I want to integrate. Let's see, I was trying to find a color that, here it is. Okay. Let's integrate both sides. Now, here I've got a y and here I've got an x, so we got to be very careful with this. Matter of fact, let's write this down and turn the board over, because we're going to need a little room here. So let's do that. I want to write the problems down, and I want to turn this board over. And every once in a while I like to give a challenging problem. I mean, you've got to know basic rules here. Okay? You got to realize, what can you do here to get this y out of the way so you can have just these x dx here. That automatically fixes this up, doesn't it? Alright, so I've got, I don't want to write it down incorrectly either, so over here, I usually have this already written down. Negative 3y dy, and I do have it written somewhere, but I don't want to look for it. E negative 2x dx. Okay, so let's flip the board over. Let's do that. Alright, here we go. Now remember, we were left with I'm integrating e to the negative 3y dy equaling e, integrating e to the negative 2x dx. Okay. Now, let's let u be this. Now, if I let u be this, I'm not going to put u on this side either. Although you probably could. Kind of like to let v be something else. But I got two different variables, that's what I'm saying. So let's over here on the side, let's let u be equal to negative 3y. Then du, the derivative of u is du, this left side, is negative 3 dy. Well, I've got dy, but I got negative 3 dy over here. So I want to multiply by negative 1/3 on both sides times negative 1/3 on this side. Notice that's over 1, remember, that divides out. And so now I've got a negative 1/3 du is equal to dy. So dy. Okay, so what I have on this left side is negative 1/3. Remember, just put that on the outside of the interval, the symbol here. Okay. Now this is e to the u du. Okay. Now let's do the same thing to this side. Can't you see this is actually going to be a negative 1/2? Okay, but let's do it anyway. So let v equal e to the negative 2x. dv, the derivative of the left side, is equal to, I'm not letting it be e, I'm letting it just be negative 2x. Okay, that's what I want. Now, negative 1/2 dx. Again, negative 2 dx, my bad. Negative 2 dx. If the derivative of negative 2x is negative 2, Kp to math G. Aren't you Kp to math G? Yes, I'm Kp to math G. Okay, but anyway, I'm also human. I make mistakes. Too many, more than I'd like to admit. Times. Now that looks better. So negative 1/2 dv is equal to dx. This divides out. Okay, so right there. Well, here we go. Negative 1/2 times the interval e to the v dv. Okay. Same idea, isn't it? Same exact idea. Now, one thing I can do, it's kind of like if I had negative 1/3 a is equal to negative 1/2 b. I could multiply both sides by negative 1 and this side by negative 1, and the negatives just go away. So 1/3 a is is equal to 1/2 b. Alright, so I could do that. If I see a negative on both sides like this, and it's all multiplication, I can quickly and easily get rid of that. Okay, so I'm just going to take away the minus sign, the negative sign. Yeah, you can do that. Okay, that makes life a little bit easier. I don't like a bunch of negative signs, do you? Okay, well, anytime you have this, you can certainly do that. Take advantage of it. Alright, here we go. 1/3. E to the u is just e to the u, isn't it? 1/3 e to the u. And then, you know, we could put a plus c1 and over here plus c2. I'm just going to put my plus c on this side. Just, you know. Okay. So just keep that in mind. This is 1/2 e to the b plus c. Okay. I could go into all this plus c1 and then c2 and all this, and actually you'd have a 1/3 c1 and a 1/2 c2, but here you can let, you know, and actually you would have a if you did this work, and I'm just going through it in my head, you could have a 1/2 c2 minus 1/3 c1 be equal to just c. I mean, go ahead if you want to put a plus c1 and a plus c2, but in the end you're just going to have a plus c. Having said all of that, did it in my head, you can just have all this. Now, u in this case is negative 3y, so 1/3 e to the negative 3y is equal to 1/2 e to the negative 2x plus c. Don't make this difficult. Always when you have two intervals like this on both sides, put your plus c on one side or the other. And I just choose to put it on the right side. Okay? And just don't make it difficult. Okay? Just please don't. It's a whole lot easier to do it this way. Well, now, what is c? We want a particular solution. That's what we wanted from the start. And our initial condition, remember, y at 0 is equal to 0. That was our initial condition from the start. Now, again, when you're taking that test, that AP exam, and you leave this c off, well, you'd be looking at this saying, oh, I'm not worried about that. Because you don't have any way of finding, you don't have a c to worry about looking for anything. You're looking, when it says look for a particular solution, you need to have a plus c on this. You will lose that point if you do not have that plus c on the end. So put it there. And if you're a regular calculus student, put it there. Get used to putting the plus c on the end. Okay? Plus c. Now, y0 is 0. This is x. This is y. Y at x. Y at 0 is the y value. So, doesn't matter. Both x and y are 0. Alright, so here we have it. We're going to find c. E to the negative 3 times 0 equals 1/2 e to the negative 2 times 0 plus c. Okay. Need a little room here. Alright. Now, hold on, guys and girls. You know what negative 3 times 0 is, don't you? And you know what e to the 0 is, don't you? Alright, well, at least let's deal with this. E to the 0 power. This is e to the 0 power, isn't it? So what we have here is 1/3 e to the 0 power is equal to 1/2 e to the 0 power plus c. Well, e to the 0 is, yeah, that's right, 1. The flashing 1. So this is 1/3 times 1, 1/2 times 1. You don't really need that. If you can just write it down, 1/3 equals 1/2 plus c. Alright, so now I'm just going to subtract 1/2 to both sides. Alright, so c is equal to 1/3 minus 1/2. Well, what's that? Let's find the common denominator. 6 is the common denominator, right, between 2 and 3. Alright, so I'm going to multiply this by 2. Multiply this by 3. Alright, so let's put it over here. Alright, so let's see. 2/3, 2 over 6. So this is 2 over 6 minus 3 over 6 is equal to c. And of course that's equal to negative 1 over 6, which is c. Alright, so negative 1 over 6 is equal to c. Go back to your original problem. Right here, you can leave it like this. C is negative 1/6, so I'm going to erase the plus c here, and we'll make it a minus 1/6. Voila. Well, okay. I don't know if you solved for y or not, but well, we could, but we're gonna just let it be. We're just wanting to figure out this c here. Oh, one more thing you could do, okay, if you really want to do that. Yeah, since your common denominator 6 is, you can multiply each term by 6. So if I multiply this by 6, this term by 6, and this term by 6, now I've got 6 over 3. 6 over 3 is 2. So I could write it as 2 e to the negative 3y. Alright, 6 over 2 is 3 equals, remember there's an equal sign here, 3 e to the negative 2x, and then 6 over 6 is 1 minus 1. So if you want to do that. And if you want to get rid of your negative exponents, so 2 over e to the 3y equals 3. Remember, just bring down the negative part over e to the 2x minus 1. I don't know. Okay, so if they said without negative exponents, if your professor or instructor says without negative exponents, then no negative exponents. Alright, okay, you got to do this then. If your instructor says, I don't care, just find out what c is, probably you could get by with just without multiplying by the 6. And I think in some cases, once you get that answer like this, you're good. Because sometimes students, especially those who are in the AP classes, will do too much and miss something here, and probably kept this as 1/6. Well, you just, unfortunately, you missed part. If you made this, you didn't multiply this by 6 on the end something, you left this as 1/6. So they're trying to encourage you to do really as little work as possible. As long as you get the C, it's alright. Okay? So in this case, C is negative 1/6. If they don't want the denominator, you have to multiply by 6. This will be it right here. If they don't want the negative exponents, just move them down like this, and you got it right here. Okay? So there it is. There's so many different ways to write this, right? So anyway. Alright. A lot of work involved here. Just understand, I want to flip this back over one more time, and so you can see what I'm talking about, that you have to know from the start to rewrite this. Otherwise, you can't separate the variables here. You've got to know that if this is plus, it's going to be times each other. If this is minus, you're going to divide. This one on top, this one on the bottom. Okay, then you can separate the variables. Okay, and that's really part of the overall battle, is learning how to rewrite, get things done. This is good here, getting it down to here, getting this up here and this up here, and actually getting it to this point here, and knowing that you got to get rid of this e to the 3y. Got these two together, so 1 over this will get rid of that. That's what you got to think. You got to do it on both sides though, and it so happens that these two are together and these two are together, and that's great. And then you can just simply rewrite this again, and then just take the integral of both sides. Okay, and really and truly, if you can get where you can see that this is a negative 1/3, and then you know that your u is already negative 3y, you can just skip right on down to this negative here and then negative over here, but a negative, I remember I just went ahead and just got rid of the negatives here. Okay, so that's it. Alright. Okay, once again, difficult problem here, but nonetheless a doable problem as well. So this is KP the Math G. Don't forget, please, if you will, to subscribe. I'm getting more subscribers. I'm getting a lot more people who are watching my videos. I do appreciate that very much. I appreciate you. And of course, if you'd like to make a comment, please make a comment and let me know. Good job, KP the Math G, or hey, I can show you an easier way. And I want to know if it's easy now. It's got to be correct though. All right. But if you can show me that, I am all ears and eyes for that matter. Okay, so please, I can get better, and I want to get better so you can get better. Okay, so anyway, KP the Math G signing off. Second day of the year, already starting with some calculus. Isn't that great? Signing off right now. Have a great day.